Okay, so this is the answers to the calculus test. Okay, so this first one is a quadratic and intersects this line at 310, and that line is perpendicular to the tangent. All right, so what does that look like? It's probably something like a U-shaped curve. There's a tangent. There's the point of intersection 310, and there's a tangent or a perpendicular to that line. So we're looking for the equation of this line. Now remember the relationship between the tangent and a perpendicular line, that slope or gradient will have the exact opposite, so it will be a reciprocal and a negative of that gradient. So what we need to do is get the gradient of the tangent, and the gradient of the tangent we would need to derive, so I'll start by doing that. Plus 7. Derive in this f dash x would be 4x, so 2 times 2, and it subtracts. We get this. I want to find the gradient at this point where x is 3, so I'll do where x is 3, and I get 4 times 3. So this will be 3. Minus 5, so that's 12. Take away 5, which is 7. Okay, so that's this. The gradient of this line is 7. So what's the gradient of this line, a perpendicular line? If 1 is 7, the perpendicular gradient will be 1/7, the reciprocal. So flip the fraction, because this is 7 over 1. Okay, we will then use this equation to get the equation of any line. I know that the gradient of it is minus 1/7. I just need a point, and we have a point. 310 is on both lines because it's where it intersects. So I'll use 3 and 10 and my newfound gradient. And then perhaps the easiest way here is to, instead of dividing these by 7, multiply the other side by 7. Oh no, let me read the question. It needs y equals. Okay, so we don't need to do that. Y minus 10 is equal to minus 1/7 x, and then 1/7, I think that's plus 3/7. And then I gotta combine this. So minus 1/7 x is okay, but that adding 10 plus 3/7 here, and I've got to combine this into one fraction, I think, which is a bit of a pain, but I'll do it. I think that's 70 over 7, this one, and so that'll make it 73 over 7. It says 10 would be 77. 77s. Okay, so that's the answer to that one. Next one, we had some trigonometry. Consider this function, and we want to just derive it and put in pi. So derive it is the division here, so that's quotient rule. And the quotient rule will start with the denominator, cosine x, multiplied by the derivative of the numerator, which is 2, because it was 2x. Subtract then the numerator, 2x, by the derivative of the denominator, which is minus sine x, all over cosine x squared. And don't forget your denominator is a dollar. Okay, so this times this is 2 cosine x. This times this gives plus 2x sine x, all over cosine x squared. So I simplified it a little bit before I substitute in this pi. So 2 cosine pi, substituting in pi, plus 2 pi sine pi, all over cosine pi squared. Now I need to know what, using my unit circle, pi is 180 degrees, so right around here, and that's cosine is the x-axis, so that is the point, minus 1, 0, which means the sine of pi is 0, and the cosine of pi is minus 1. So we have 2 times minus 1, 2 pi times 0, all over minus 1 to be squared. So the cosine pi is replaced with minus 1, and the sine pi became 0. Work this out, I get minus 2 all over, so this is just 0, and this is 1, so the answer is minus 2. Moving on to question 3. I think we have another quotient rule here. The very first start of this just asks for a straight derivative, so I should be able to use the quotient rule again. So it is, the derivative will be the denominator times the derivative of the numerator, which once again is 2, times the numerator times the derivative of the denominator, which is just 1. All divided by 1 plus x to the squared, the denominator squared. Multiply this out to simplify it. I would probably give you full marks for this, which probably should simplify it because we're going to need to use it in the next part. 2 plus 2x, and I think this gives minus 2x, all over 1 plus x squared. This cancels with this, and therefore 2 over 1 plus x squared. Remember, the entire denominator is squared, not just the x. The 1 plus x has to be squared. Okay, the second part, determine the equation of the normal. So once again, this is a curve of some sort, and we want the normal, not the tangent, but they share this point, minus 2, so they make this kind of shape, and we got minus 2, 4 here. We can get the gradient of this, and then do the reciprocal and change the sign, and it'll be the gradient of this, because we want to fill in this formula to get the equation of this normal line. It's a line. Okay, so how do I get the gradient first, which is m? I'll use the tangent, which if I sub in the point at minus 2, because the point is minus 2, 4, I'll get the gradient of this line, which is not the normal, but it'll help me find the gradient of the normal. So that's 1 minus 2 to be squared. So I just substitute x in here. And I think I get minus 1 squared. I think that's just 2. And once I have that gradient, I know the gradient of the normal then. So this one is 2. The gradient of the normal is minus a half. So if this is 2 over 1, you flip it and minus a half. They share that point. So this point, this gradient, and I'll just find the equation of the line then. Y is 4 from the point here, minus a half, x minus x1, which from here is negative 2, so minus 2 is plus 2. And then I will rearrange. I'll multiply out first that bracket, so that's a minus a half x. Minus a half of 2 is just minus 1, I think. Half of 2 is 1. And then bring over the 4, become plus 4, so I get plus 3 Excuse me. Okay, and that's that done. Next question. Caused a few problems, this one, because we weren't too sure how to show that a point lies on a curve. You substitute in. So you have this fx is equal to kx cubed. Remember, this is y is equal to kx cubed as well, and I have some point, 2 and 8k. This is x and y. If it is on the curve, it'll work perfectly for this equation. If it is off the curve, it won't work. It'll give a nonsense answer. So let's see if it does work. So if I sub in 2, I should get out 8k. So if I sub in 2, I get k times 2 cubed, and that is 8k. And that does work. So y is 8k, so it is on the curve. It works out. If it gave 10k, it wouldn't be on the curve. The second part, at P, so this point P, I'm not too sure how well I've drawn this. The normal to the curve is parallel to some other random line. So at P, there's some normal. So I've drawn a tangent, then a normal. And this normal is parallel to some other line. This one. Let's just say it's over here. Those two are parallel. So the gradient of this one is 1/6, which means if they're parallel, the gradient of this one is 1/6. So what's the gradient of the tangent? We have to work back to find the gradient of the tangent. The gradient of tangent then is minus 6 over 1, the opposite one. Why does that help? Because I know if I derive this, which is part B, if I derive it, if fx is kx cubed, and I derive it, f dash x is, now k is just a number, so 3 times that number minus 1. So the k, if this was 2, you'd go 3 times 2, but we don't know what it is, but we will end up multiplying it. It is not the variable. It is a number. It is, x is the variable. So you don't have to treat it like the product rule. Okay, so that's the derivative. I know that the gradient is minus 6 at this point 2, 8k. So 2, when x is 2, from this, I know the gradient is minus 6. So when x is 2, I know that gives out minus 6 as an answer. And that will help me find k. That was technically probably the hardest question on the exam to understand how to actually find the answer. So that's minus 6. Squaring that gives 4. 4 times 3 is 12. And then divide that, minus 6 over 12 is equal to k. So k will be negative. Okay. Next question. So we have these two separate functions here. We need to be able to get the derivatives. They're separated, so I can do them separate. So what's the derivative of this and derivative of this? Well, if you're not sure, you can always just go to your quotient rule, because that's a fraction and that's a fraction, and we do them separately, we add them together. So the derivative is, so I'm going to use the quotient rule. 5 minus x numerator times the derivative denominator, which is, or the numerator, which is 0, minus, so I'm just doing this first one here, minus the derivative of the, or 9 times the derivative of the bottom, the derivative of the bottom minus 1, I think, the minus x, all over 5 minus x to be squared, plus, okay, that's that one done, and we do this one. We know the denominator is going to be x minus 1 to be squared. We do the same process then. X minus 1 times 0, the derivative of the top is 0, minus 1 times 1. The derivative of this is going to be 1. Tidying this up a bit, well, this doesn't matter because it goes to 0, and so does this go to 0. So you just have minus 9 times minus 1, which is just 9. And here we have, on the other side, that's the denominator is okay, we just have minus 1. So perhaps making this a little bit easier, I'll just change this plus to a minus, move that, and apply the minus in, so it's just easier to deal with from now on. Find the x coordinates where the gradient is 0. So where the gradient is 0, so I want to find x when this is 0. So the derivative will be equal to 0 when the gradient is 0. Because this is, the derivative is the gradient function. It gives you the gradient. How do I solve this? A little bit of a tricky one. Let's have a look. We will probably have to use a common denominator, but I'm going to just add this over the other side. And now this makes it a slightly easier solution because I can cross multiply here. And now, so technically I'm doing a common denominator and then ignoring it. The common denominator would be this times this. Right, I just got to work this out. So x minus 1 squared, I got to be able to do quite quickly. And this one is just going to be 5 minus x, so I give 25. If it's multiplied by 1, it doesn't matter. So minus 10x plus x squared, I think. I'm going to multiply this by 9 on this side next. 18x minus 9 is equal to 25 minus 10x plus x squared. Bring everything to one side. I think I have 8x from this one away from this one. Adding this 10x over, I get minus 8x. And then 25 and this positive 25. Oh, hold on. Oh, this should be plus 1. Sorry, minus 1 squared is plus 1. So that's going to be plus 9. 25 over here, it makes minus 16 is equal to 0. Okay, this is better. Divide everything by 8. I think a common denominator, a common factor here. And I can factorize this then. I have x and x, give x squared. 2 and 1 and that's an x. I think that's minus, that plus will work out, so I get x minus 1 from this, and x equal to 2 from this. So I think the x coordinate of the points is all I needed to find, and that is the 2x coordinates. Question 6. Well, it starts off, they've given you some function, looks like a cubic function, and it is. We're missing this k here at the end, but we need to find the first derivative and second derivative, so we will do that first. So we have this function. Finding the first derivative then by rule is 3x squared plus 6x minus 9. What do I do with the k? Well, the k is a constant. It's just a number. It's got no x with it, so it would disappear. Part 2, find the second derivative. I will. 6x, multiply down, and 6. Okay. Part B then, find the coordinates of the point of inflection. So the point of inflection, we should know, is let the second derivative equal to 0 and solve to find that point of inflection. So 6x is equal to minus 6 and x is equal to minus 1. That's the x coordinate of the point of inflection, which makes sense with my graph. This is the point of inflection here, C, where it changes from sad face to happy face, concave down to concave up. Given that, so we're starting off with part C, given that the function with minus 1 put in it equals 14, find the function with 0 put in it. Okay, so let's use the function with minus 1 put in it. F with minus 1 I know gives 14, so I'll put minus 1 in to the function, and I know that should give minus 14, or just positive 14. So I'll put in minus 1 for my x's, and that will give 14 out. So I get minus 1 here. I think this gives positive 3. This gives positive 9 plus k is equal to 14. So this is going to help me find what k it is. So this is 12, take away 1 is 11. I bring that over, that subtracts 11. So k is equal to 14. Subtract 11, k is equal to 3. Once I know that k is equal to 3, find f with 0 in it. F with 0 in it is going to be, well, that's 0, 0, 0. We're just going to be left with k. So f with 0 is just equal to 3. Now you could literally put in 0 and use k as 3 and find it if you want. Part 2. Hence, find the coordinate of the local maximum, which local maximum. So we have to find this coordinate. Oh, it's not on the screen. This coordinate where so the derivative will equal 0 at the maximum and the minimum. So we find when we let it equal 0, we'll find the max and the min. So I'll just do it here, not to switch the page. Part 2. The first derivative would equal 0. So 3x squared plus 6x minus 9 equals 0. So I'll have to solve this to find out where the gradients are 0 at the max and min. You'll find both the max and min here. So divide by 3 to start off with to make it a little bit easier to factorize. We'll factorize this. Of course, we should have recognized this is a quadratic ready to be factorized. 3, I think we need to go plus and minus, plus 3 minus 1. So x is equal to 1 and x is equal to negative 3. Now there's a couple of ways of figuring out which one is the max and which one is the min. You can substitute these back into the function and find out which is the bigger value. Or the other way is just look at the curve they've given us. A must be at minus, the maximum must be at minus 3 because we can see that. So I need to find the full coordinate, so I need to substitute. So at the moment, I just have the x coordinate, that's minus 3 something. So how do I find out what something is? Well, I use my original function to find that something. So y is equal to x cubed, I'm using this one, which is minus 3 cubed plus 3 times minus 3 squared minus 9 times minus 3 plus 3. We already found that k was 3 earlier on. If I do all this out, I think you get 30 because that's 20, that's minus 27. I think it's 30 if you work it out. and your point then is minus 330 is the max point. Okay. Part D, hence write down in order from least to greatest the second derivative at B, the first derivative at B, and the function at B. So B then, so you're kind of looking at the y values of these, which is going to be bigger or smaller. So we just use the graph to figure this out. So f at B is less than 0. So I think so that's going to be definitely, look, the function already at B is less than 0. So f at B is going to be less than 0. The first derivative at B is going to be, that's at the minimum. So the first derivative is 0 at B. So the first derivative at B is equal to 0 because it is right here at the minimum. And what's the second derivative of B going to be? Well, because of its concavity, this will give a positive answer. A positive answer because it's a happy concavity. Give a positive answer, so it's got to be not equal to 0. It's just going to be greater than 0 because concavity switches from sad concavity to happy concavity. It's in the happy part, so the second derivative. Remember, the point of inflection is where it is 0. So if I draw that, point of inflection is where the second derivative is equal to 0. Here we'll give positive. Here we'll give negative. Happy face, sad face. Positive answers out of all this. Okay, so in order from smallest to biggest, f of b is less than 0, so it is smallest. Then f dash b is equal to 0, so it's in the middle. And this one's definitely greater than 0. So it is the biggest. Okay, so that was, I think, you might have got the first two. You might have missed the fact that the concavity thing here gives a positive with a happy face. And our last question. Okay, I think this was a bit easier than you guys might have made it out to be. But we will do, especially part B. Part A, most of you did okay on. The first derivative of sine x, so if fx is sine 3x, what is the derivative of that? Bit of chain rule here because we've got 3x inside. So the derivative is going to be minus cosine x, but, a positive cosine x, but cosine 3x, but I need to multiply by 3 afterwards, which is the derivative of the 3x. And that will give a 3 cosine 3x. Part 2 then, find the derivative of a natural log function. So the first derivative of this is another chain rule. It's 1 over 2x plus 1, but I need to multiply then by the derivative of this, which is 2. So it is 2 over 2x plus 1. Remember, this is a function within a function. You're going to deal with that afterwards by multiplying it afterwards, the derivative. Okay, so that's part 1 and part 2a. Part B then says h of x is f of x times g of x. Okay, so that's right then. H of x is the f of x function, sine 3x, times this one. And they want to find the derivative of this function with pi over 2 subbed in. Now this is a function times a function, so it is product rule. And how do we do product rule? Well, the first by the derivative of the second plus the second by the derivative of the first. So the first, sine 3x, multiplied by the derivative of this. Now we've just done this. The derivative of this is 2 over 2x plus 1. Plus the second, which is ln 2x plus 1, by the derivative of this, which we also just found. So they set it up for us to find it. Now, in the exam, try not to go outside these lines, but I'm sorry. At this stage, I'm not going to simplify this. I am going to sub in, and then I will find out. So this is h dash x. I already did it, this product rule. So h dash pi over 2 put in. I'm going to put pi over 2 in for all these x's. So sine, 3 times pi over 2 is 3 pi over 2. And that's multiplied by 2 over 2 times 2. 2 times pi over 2 is just going to be pi plus 1. See that? Okay, see that. Plus ln. 2 times 2 pi is going to be ln pi plus 1, I think, times 3 cosine 3 pi over 2. So it looks like we need to use our unit circle and find out where 3 pi over 2 is. It's down here, of course. So what is the cosine? The cosine at that point is 0. And the sine at that point is minus 1. So we know the cosine is 0, which means this is 0. Which means that all of this side of the equation goes to 0 because it's all multiplied by this 0. So I don't need to worry about that anymore. So I'll just do this side. What's sine 3 pi over 2 is minus 1. So it's minus 1. Sine is the y value. Times 2 over pi plus 1. Which becomes minus 2 over pi